Well, hi everybody, welcome back. We're still on the last part of our chapter on vectors, and we're going to be looking at example number 411 right here. So, and this is in our notes. It's not a homework question. It's from our notes. So, I guess this is kind of appropriate for the holiday season coming up and all kinds of shopping going on. But we have a couple that is at the mall, and he wants to go up, and she wants to go down. So they're going up escalators, and they're starting on whatever floor you want to call that. He's going up, she's going down. And the angle at which these escalators actually exist is 45 degrees from the horizontal. So that right there, that's 45 degrees, as is this right here. 45 degrees. So the question is, what is the husband's velocity with respect to his wife? Well, before we can actually do this, we need to write down our equation for how we want to relate the husband to his wife. And we need to relate both of them. Since they're both moving, we need to relate both of them to a stationary object. I would say the floor. I'll call this the floor right here. Of course, they're both standing on some kind of a floor, but oops, sorry about that. But that's the floor that we'll relate both of their objects to. So that'll just be F, our subscript F right there. And this is our husband, H, and our wife, W. Okay, so what we're going to say is we're going to say that the velocity of the husband to the floor, and we're told that, we'll write that down in just a second, we're told that both of them are moving at a certain velocity, but the velocity of the husband with respect to the floor plus the velocity of the floor to the wife equals the velocity of the husband to the wife. Okay? Husband to the floor, floor to the wife equals husband to the wife. Now, right here, let's look at this for a second. I'm going to change colors to black. Is the floor moving with respect to the wife? Well, kind of. I mean, if they're the only two things that exist in the universe, yeah, then they're both. One of them is moving with respect to the other. So who knows? The floor can be moving, the wife can be moving. You can think of it that way, but it makes more sense for us to think of the wife moving with respect to the floor. So I'm going to erase this right here. So if you recall from class how we can change this around to make it make a little more sense, is we can write it like this. Velocity of the husband, oops, that's in H, husband to the floor. And how do we turn this around? Well, if we say the velocity of the wife with respect to the floor as well, we can certainly do that, but we have to change the sign out front. So, plus negative velocity of the wife to the floor, okay, that's a vector, equals the velocity of the husband with respect to the wife. All right. So, well, what is the velocity of the husband to the wife? Well, we're told that each of these right here, that velocity and this velocity right here, are both what? Both escalators are moving at 2 meters per second. 2 meters per second and 2 meters per second. But what we really want to be able to do is to set up is to break these velocity components down into their x and y components, or these two velocities down to their x and their y components. So we're going to set up a chart. And this is where your knowledge of knowing how to do the component method really comes in handy in setting up the chart. We're going to really be mixing the component method with the unit vector method in many of these cases. But all the way over here, I'm going to start my little chart. So equation, or you might just say vector, or some vectors can be expressed as an equation. That's going to be our first column. And then magnitude, and this should start looking more familiar to you. Theta, x, or you might say x hat, and then y, you might say y hat. It's the worst straight line I think I've ever drawn. That's a little better, but not much. Doesn't help my computer's a little jumpy here, but that'll do. All right, let's write this in black so it actually stands out. So the velocity of the husband to the floor. Well, that's not black. Come on now. There we go. Velocity of the husband to the floor. The magnitude is what? Well, we said it was 2 meters per second. The angle with respect to the horizontal is 45. 45 degrees. So that means what's our x component? Well, that's, if you remember, that's our magnitude cosine of theta, and the y component is magnitude sine theta. So if we punch them in, we're going to get an x magnitude of 1.41 meters per second, and a y magnitude also of 1.41 meters per second. If you think about it, they're both positive because the husband is moving positively x and positively in the y direction. But the velocity of the wife to the floor, well, the magnitude is still 2 meters per second, and the angle is still 45 degrees. But the x component still going to be positive 1.41 meters per second. But the y component, we're going to look at it and we're going to see that it's going to be negative because she's moving downwards with respect to the floor. So if the floor is stationary and the wife is moving, she is moving downwards. So she's going to have a velocity of negative 1.41 meters per second. Okay. So we have an x component and a y component of each. So now what we can do is take these two vectors, husband with respect to the floor, wife with respect to the floor, and simply add them up, and we can get our velocity of the husband to the wife. So let's do that right now. Before we write this out, we should probably make it a little bit clearer right here. This right here, we really don't like to subtract vectors, but we can. Hey, my wife's coming in. Hey, hon. She's putting her computer away. We don't really like to subtract vectors, but we certainly can using the unit vector method. And I'm going to take this and I'm going to change it to just a straight minus sign. So the velocity of the husband to the floor minus the velocity of the wife to the floor is equal to the velocity of the husband to the wife. All right. Now, if you recall from unit vector addition and subtraction, we actually can subtract unit vectors. We actually have an equation for that, so that should work for us. So let's see if this straightens things out for us here. Velocity of the husband to the wife equals, okay, now let's subtract the x hats. 1.41 minus 1.41. Okay, that's right out of our notes on how to subtract one unit vector from the other. X hat, right? Because that minus that x hat plus, now let's subtract the y hats from each other. 1.41 minus negative 1.41. This should make a little more sense to you. Sorry about that last little snafu there. 1.41. Everybody see what we did? We subtracted one vector from the other in unit vector form. And this is right out of a couple pages back in our notes, where we have the difference of one plus the difference of the other. Oops, I forgot my y hat here. Come on, y hat. There we go. All right, now what does this simplify to? Well, you can probably tell it simplifies pretty simply, as it were. Velocity of the husband to the wife is equal to nothing in the x hat direction. And that makes sense, because if they're both moving forward, she's moving forward and down, he's moving forward and down, they're basically going to stay directly on top of each other vertically. So they're not moving at all side to side with respect to each other. They're staying lined up directly vertically. But they are going to have a difference in velocity in the y direction. So 1.41 minus negative 1.41, that would be 2.82 meters per second in the y direction. And that right there, my friends, is the relationship of the husband to the wife as they're moving. As they're both moving forward in the x direction, but she's moving down, she's moving up. She's moving down, he's moving up in the y direction. They are getting further and further apart from each other to the tune of 2.82 meters per second y hat, or in the y direction. So there's no change in the x direction. You can see right here they stay pretty much the same in regards to the x direction, but in regards to the y direction, they're getting further apart at 2.82 meters per second. So that's example 411, and that's the last one out of our book, or out of our notes. We do have a couple others that we have as addendum problems. We'll take a look at them later. I will see you then.